At the far northern borders of India, military outposts sit perched on thousands of feet of ice and rock, where temperatures drop well below zero. Southwest, in the Thar Desert, the environment flips to a scorched, arid expanse of blistering sand. The northeast is defined by torrential, unending rains, while the south softens into dense, mist-covered green tea plantations. India contains some of the most extreme topographical and climatic opposites found within a single country. About 55 million years ago, the massive Indian tectonic plate drifted north and collided with the Eurasian Plate. That single event buckled the Earth's crust, thrusting the floor of an ancient sea into the sky to create the highest peaks on Earth. This collision established the architectural foundation of the subcontinent. To see how it functions today, we have to trace the geography from north to south. The journey begins at the absolute peak, the Trans-Himalayas. This high-altitude band houses the Karakoram, Ladakh, and Zanskar ranges. A deep fault line called the Indo-Tongpo Suture Zone marks the break between these northernmost ranges and the main Himalayas. Below that fault, the ancient Tethys Sea was violently compressed between converging plates. The sediment was folded upward to form the mountain peaks. These young fold mountains run in three parallel bands: the Great Himalayas, the Middle Himalayas, and the Shivaliks. This massive vertical scale captures and stores moisture as ice. These ranges act as high-altitude water towers, feeding the entire subcontinent through the spring melt. To the south, in Rajasthan, the Aravalli Range provides a sharp contrast. These are among the oldest fold mountains on Earth, now slowly eroded into rocky, weathered ridges. The Aravallis act as a climate divider. By blocking moisture-rich winds from moving west, they effectively starve the land of rain, resulting in the Thar Desert. In central India, the topography shifts from folding to faulting. Here, the Vindhya and Satpura ranges stand as massive block mountains. As the crust pulled apart, massive sections of Earth sank to form deep rift valleys. This specific geometry forces the Narmada and Tapti rivers to flow westward through these trenches towards the sea. To the east, the Shillong Plateau and Meghalaya appears connected to the mountains, but its rock reveals it is a fractured piece of the southern peninsula. The Garo, Khasi, and Jaintia hills form a natural funnel. This traps incoming monsoon winds and forces them to dump their moisture, resulting in the relentless rainfall recorded at Masanram. These central and eastern formations act as the master switches for India's weather, segregating the driest regions from the wettest. The southern peninsular plateau is framed by the western and eastern Ghats, which converge at the Nilgiri Mountains. The central Deccan Plateau formed through fissure eruptions. Red-hot magma oozed from Earth's cracks, blanketing the region in lava. This basalt weathered over millions of years into rich black soil, a geological legacy supporting today's massive cotton industry. Further east, the Chota Nagpur Plateau holds immense mineral reserves of coal, iron, and copper, concentrated by ancient tectonic pressures. This southern half of the country is a geological vault, housing the agricultural and industrial wealth that sustains the nation. Across the subcontinent, these mountains and plateaus function as the primary life support systems for over 1 billion people. The icy heights of the Himalayas birth the perennial rivers, like the Ganges and Indus, which irrigate the massive northern plains. In the south, the plateaus provide the raw materials required to drive the modern economy. Millions of years of tectonic shifts and volcanic activity dictate exactly where cities grow, what crops survive, and how the nation profits. Every line on the map of India tracks the output of this ancient geological engine, the structural force that continues to build a civilization.